Hi there, this is Chapter 8 Notes for Modelling Growth and Decay using Recursion. Before we go through these notes, I just want to make note that if you are doing exam revision, this is the 2015 exam. Up this year now that the coursework has changed, if you're doing exams from 2015 beforehand and you're looking for some of these modelling growth and decay questions, you need to go into Module 1 and look at some number pattern questions. This was previously up to now, it was part of the modules. However, now this modelling growth and decay has become part of core. So if you're looking at past exams, go to Module 1 number patterns for further examples of these questions. If this is too dull, you can follow along with your printed notes. So if you see V subscript 0, so V0, what this means is this is our starting value. So if we were buying a car, the car's worth a certain amount of money, that's what you start at, your V0, before you go any further, your starting value of that car. If you see, for example, V1, this means at the end of that value, so at the end of year 1. So if it was V2, it'd be at the end of 2. Be careful with these little subscripts, but generally you'll see the V0 question, so that's your starting value. If you're not using any rules and you're just really quickly trying to calculate values using the V1, V2, V3, V4, you can use AND's function on your calculator and just keep hitting enter and just count how many times you hit enter to find further values. Now, looking at recurrence relationships, this is when we're using the previous value to predict the next value. So we might be using the value of V6 in a formula to find out what the value of V7 is. This will have a V0 equals in the relationship. So there will be that starting value mentioned in the relationship. A rule is when we are finding any value by using that value's position. So if we want to find V5, we need to use N as 5. So what number value that is, so V5 would be the number value 5. So you would use 5 in the subscripts. Now let's have a look. There's two types of rules and recurrence relationships. One's for linear, one's for geometric. Let's have a look at the linear relationship first, so straight line. I've given you here a worked example just to show how these rules and recurrence relationships come about. So you can have a look at that, try to understand that if you want. However, the two things you just need to know are the rule and the recurrence relationship formulas. So for linear, here's our formula here. If we want to find V5, so that N is a 5, you'd use 5 here in the rule. And so this one is predicting if we want to find V10, we use 10 there. Work out the difference, and that comes from all the way back. Use this example here to help you. If you want recurrence relationship, it looks like this. V0 equals something, and there'll be a Vn plus 1 equals. On your SACs, quite a few people made the mistake of not identifying when the question asks for the rule, you gave the recurrence relationship, or vice versa. Be very careful in your exams. Read what it's after. Is it after the rule, or is it after recurrence relationship? So use these two structures just to fill in the information of the D and the N, etc. For geometric, so geometric is when it's not linear, it's curved, so it's not straight line. Once again, I've given you a worked example here to show you how the formula, the rule and the recurrence relationship are found. However, in your resource booklet, once again, you can just place in these formulas for the rules and the recurrence relationships. So once again, if we're trying to find V5, you'd put 5 up here and you would have your value for your R. Recurrence relationship, once again, is a VO equals, or sorry, a V0 equals. Once again, is the question asking for a recurrence or is it asking for a rule? Make sure you read the question. Now, with the geometric, if it's going to be a growth, R is going to be greater than 1. If it's going to be a decay, R is going to be less than 1. So have two calculators to make calculations easier. Have your CAS calculator and have just your scientific calculator. Sometimes it's actually easier and quicker to use your basic scientific calculator than your CAS. Instead of using the touchscreen, it's easier just to use your scientific calculator. So with working out growth and decay for geometric recurrence and rules, you've got to have a look at how much something may be increasing or decreasing in a percentage. So if something is in our rule, R is 1.15, what does that actually mean as a percentage? So you want to start at 100%. And if something's a decay, it's going down. If something's a growth, it's going up. So let's use 15% for the example. If we're starting at 100%, we grow to 115%. That, as a decimal, you can just divide by 100, is 1.15. So if you see that in a question, you have to be able to identify yourself that it's a growth of 15%. Let's do a decay example. If it's 100%, we decay by 15, we go to 85%. As a decimal, it's 0.85. So once again, this is a decay, but you need to be able to just look at that and identify that 0.85 is a decay of 15%. So that would be on your R values. Do a bit of practice with this because it can save you a lot of time. Now, make sure you read the question. If it's asking per annum, so PA, or it's asking per month, you may need to calculate your interest rate for a month, quarter, day, etc. So read the question. The formula that they've given in the question may be talking about months, but the actual question that they're asking you to answer might talk about the yearly percentage rate. So just be very, very, very careful, or it might go backwards the other way. So if it's 12% per annum, there's 12 months, so it's 1% per month. So you may potentially have to use the 1% in your question. Using the solve function on your calculator, there's a little button that looks like this. It says solve and it's a bracket. You can use this at any stage throughout your exam. Press solve and place in your formula. So if we, for example, had a formula like this and we needed to solve for n, so we needed to find how many months or years or whatever that question may be asking, you can place that into your calculator, comma, and then put the variable you were looking for. This is the important part at the end. So if you're just going to put in the formula, it's not going to work. You need to put comma and then identify the variable you're looking for. That will solve the answer for you. So instead of taking a lot of time to try and solve this by hand, your calculator can do it for you. And the last part is effective interest rate. So if you can follow along these lines to find your effective interest rate, and be very careful of your compounding periods. Per annum is once a year, monthly's 12, quarterly's 4, weekly's 52, fortnightly's 26, and daily we use 365. So we don't use the leap year, we just use 365 as a standard year. Thank you.